Hey everyone, welcome to the first video for chapter 4, which is all about areas of polygons, but today we're talking specifically about areas of parallelograms. Alright, so before we begin, there's a couple things we need to be good on. It is finding areas of squares and rectangles, okay, and then also plotting ordered pairs. So let's talk about and recap the areas of squares and rectangles first. Okay, so if I said, hey, find the area of that rectangle, what would you do? Well, hopefully you would say, well, I remember the area of a rectangle is equal to its length times its width. Okay, and so in this case, the area is going to be equal to the length of 18 times the width of 12. Now, could I have done 12 times 18? Yes, you could have. It's totally fine. With rectangles, it does not matter. So anyway, 18 times 12. Well, that's like 18 times 10 plus 2. Right? That'd be 12. And so that's 180 plus 36. And that's going to get you, of course, 216. Now, we weren't given units here, so we would write then as our label, units squared. But if it was, inches and inches, we would say 216 inches squared. Millimeters, the whole deal. But 216 square units in this case. There were no inches given to us. Like I said before, the other thing we need to be good on in this chapter is plotting ordered pairs. So let's go over here and work on that. Let's plot the points or ordered pairs 3, 5, 0, 7, negative 4, 2, and 2, negative 5 on the coordinate plane here. Okay, remember the grid is also called the coordinate plane. So 3, 5. Remember, when we plot points, we go left or right first, and then we go up and down. The reason for that is because a point comes to us in X, Y format, and if you notice, we have our X-axis running this way and our Y-axis running that way. So we do the 3 first in this case, and it's going to be either a left or a right move. So, as you notice, if you go left, they're negative numbers. If you go right, they're positive numbers. So 3, 5 would be right 3 and then up 5. So the point would be right there. Okay, you guys are doing your notes on graph paper anyway, so you're going to have these grids almost available to you. You're just going to need to sketch on your x-axis and your y-axis. All right, 0, 7. Left and right 0, and then up 7, so that's going to be right there. Negative 4, 2 is going to be going left 4 and then up 2. And lastly, 2, negative 5, we're going to go right 2 and then down 5. And so we're right there. So yeah, that's going to be very handy as we get into this chapter. Alright, so first let's talk about polygons, okay? So what's a polygon? Polygon's a pretty general term, and it means a polygon is a closed plane figure, okay? So you notice all these shapes down here, I don't have any openings in them unless they were little errors in my drawing like that, but none of them look like that, right? That's not a polygon. So polygon, again, is a closed plane figure made up of 3 or more line segments that intersect at their endpoints, okay? So we got rectangles, parallelograms, which we're talking about today, trapezoids, pentagons, triangles, hexagons, octagons, and so on and so forth, right? It keeps on going. Those are polygons. Alright, so today, like I said, we're talking about parallelograms. So what's a parallelogram? It's just a 4-sided polygon whose opposite sides are parallel to each other. So we'll draw a little parallelogram here. Okay, that's a lot of times what we see looking like a parallelogram. These two are parallel to each other, and those two are parallel to each other. And again, what does parallel mean? It means they're never going to keep on going and eventually they cross and run into each other, right? It's not a triangle, it's not a trapezoid, it's a parallelogram. Those two are parallel to each other, those two are parallel to each other. But also, a parallelogram, you might think of a more common one as that, a rectangle. Parallelograms or rectangles are parallelograms. Those two are parallel, those two are parallel. Closed plane figure, so it's a polygon, and more specifically, it's a parallelogram. So a parallelogram is a type of polygon. Alright, so let's talk about the areas of parallelograms, okay? So, well, didn't we just say that a rectangle was a type of parallelogram? We did. And how do you find the area of a rectangle? Well, you guys know that. It's length times width. So what about a parallelogram that looks like this? Almost an identical formula. In fact, it really kind of is, except we use different letters. Instead of length times width, that, instead of being the length, is what we call the base, and then we're going to multiply that by, instead of this being the width, we have a line that's going to form a right angle at the bottom, and that is called the height, And so the area is base times height. That is how you find the area of a parallelogram. All right, so let's find the area of this parallelogram here, okay? So we remember that the area of a parallelogram is found by doing base times height. So in this case, my base would be the 8. So let's just plug in 8 where the b was, times our height, which is going to be perpendicular to this 8. It's going to form a right angle. And if a right angle is formed up here, and it's a parallelogram, there's also a right angle formed right there. Okay, so these two dimensions form a right angle, so that's the base, so that 13 is going to be our height. And so then all we have to do is go ahead and say, well, what's 8 times 13? 8 times 12 is 96, so add another 8, and you get 104. And there were no units given to us here, so we're just going to write units squared as our label. Easy as that. Alright, so I want you to go ahead and pause the video, and I want you to find the area of this parallelogram. Play the video when you're done. Alright, so you remember area of parallelogram, base times height. So what is the base in this case? The base is 7.2. So where the b was, I'm going to put the 7.2. And we're not going to write millimeters in there because it kind of crowds things. We'll take care of the labels at the end. So base times our height. What's our height? Our height in this case is the 3.1. So now all you have to do is multiply. And when you do 7.2 times 3.1, okay, you guys know how to multiply, you get 22.32. And so our answer is A equals, for area, 22.32. And what's our label? Well, remember, labels are actually kind of interesting because we know if I give you the expression m times m, you would say that's m squared, right? If I said, hey, write k times k with an exponent, you'd write k squared. So in this case, we were actually taking something that had millimeters attached to it times another thing that had millimeters attached to it. And so if I have a millimeters times a millimeters, guess what that is? Millimeters squared. So that's why that's one of the ways you can think of labels as being squared. We also remember that area is all about an object, a flat object, taking up space and square units, right? So we could really impose a grid over this parallelogram like this. Okay, this is really sketchy and it's probably not going to work out perfectly, but what it means is that if we counted these boxes, if I laid it out correctly, and again, this is just a quick example, if we counted up all these boxes, that would be how many squares? There'd be 22 and 32 hundredths of a square counted up in there. So again, area, square, units. All right, same kind of problem. I want you to go ahead and find the area of this parallelogram. So try it out, play the video when you are done. All right, so what are the labels? Well, there's no labels given to us, and so we're going to use units here. All right, so let's count our base and we'll count our height. It wasn't given to us, we just got to count it out. So starting here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then for the height we count this way, right? Wrong. Remember, the height forms a perpendicular, it's perpendicular to the base, or it forms a right angle. So you could count from there, or you could count from there, or from there, or there. It doesn't matter. They're all going to be the same. So let's just count from, I don't know, let's just do here, okay, against that line or on that line. So starting here, 1, 2, 3, 4, 5. The height is 5. So what is the area of this parallelogram? Well, remember, base times height. So in this case, 8 times 5. And what is 8 times 5? 40. Okay, and then we use, again, square units or units squared. All right, so let's try this one out. We're going to calculate the area of the white region here. Now, this is a little bit more difficult because this is not part of the white region, right? It'd be one thing if it said, hey, calculate the area of the parallelogram, 8 times 7. But we have this here. But I think it's a little bit easier than maybe it looks, because really the white region is an entire parallelogram minus this rectangle, right? That would leave us with the remaining white area surrounding this blue rectangle. So let's do that. What is the area of that parallelogram? Well, it's got a base of 8 and a height of 7, so that's 56. And then we got to subtract, though, the area of the rectangle, and that's 3 by 1, so 3 times 1 is 3. So let's go ahead and just kind of finish that out. 56 minus 3 is 53, and it's talking about feet here, so it's feet squared, or square feet. 53 square feet is the area of the white region. Alright, that's all I got. I'm done. See you guys in class.